Welcome to Maths with Bob. Today we're looking at surface area and volume, and in particular cones. So I'm going to start off by looking at how we get this formula for the surface area of a cone. Now, the first thing is let's actually just draw a circle. Okay, let's cut a piece out of it. Okay, call the radius L. Okay, this is the center, if you like, O. Let's call this point A and B. Now, okay, so we're going to actually basically form a cone by pulling A and B together. So we're going to basically, if you like, cut this bit here out. Okay, and if you like, pull A and B together. So we're going to pull A and B together. Okay, they are going to, so A and B are going to join here. Okay, this is going to form a cone. It's going to have a radius, obviously, of R. It'll have a height of L, and in fact, this bit down here actually will be L. Okay, so the first thing to do is, what would the length of AB be? Okay, so you can see AB would actually be the circumference of that new circle of radius R. So AB's length would be equal to what? 2 pi R. The R coming from the radius of the cone, right? Okay, so let's have a quick look at some ratios. So the ratio of the area of the sector, which is what we want to find. So this is what we want to find basically is this bit here. We actually want this bit, which is the bit that wraps around the cone. Okay, this is, let's call that AS, if you like. AS, the area of the sector. So what are we after? We're after AS. So the area of the sector, okay, to the area of the circle. Now the area of the circle would be what? Pi L squared. Okay, well that should equal the length of the sector to the circumference. Now the length of the sector, well that's just AB, which we know is 2 pi R, okay, over the circumference of the circle, okay, the original circle, which is in this case, what's that, 2 pi L, right, 2 pi L, and you can see this will just cancel down to something nice. What's that? Just R on L. Okay, so let's actually just now rewrite this. What is AS? Okay, so AS is equal, that's the area of the sector, okay, which is the curved part of the cone. Okay, now, so that's going to be R on L times pi L squared, and you can hopefully see that the L, one of the L's will go. Let's just cancel this. Okay, that L will cancel with one of those, and it'll just give us, okay, pi RL. Okay, so that is, if you like, this bit that's wrapped around this cone here. Okay, so it's, well, if you like, the curved surface area of the cone part is pi RL, plus we have the area, obviously, of the base, pi R squared. Okay, so let's actually write down what the surface area of a cone is. Okay, well, the surface area, okay, of a cone is that curved part, which we just worked out, was pi RL. Pi RL. L is actually called the slant height sometimes. And there's also a pi R squared as well, coming from the circle, base of the circle. Pi R L plus pi R squared. Okay, so this is the surface area formula. Now the volume of a cone, we'll do an example in a second. Okay, now the volume. Well, first up, these are, if you like, a pyramid of sorts. So the volume is, okay, 1/3 the area of the base times the perpendicular height, which you can see here is 1/3 pi R squared height. So this is the volume formula for the volume of a cone, because it's actually a circular pyramid. Okay, so let's actually have a look at an example. Okay, well let's actually put some measurements in. So let's actually make L, say, 13 centimeters. Okay, and the radius, let's make that, say, 5 centimeters in here. 5 cms for the radius. Okay, so let's try and work out what the surface area would be. Well, Okay, you can see here the surface area is pi RL. Okay, let's have a look. Pi. Now the radius is 5 and L is 13, so that's 65. I'll just write in 5 times 13. Okay, which we know is 65 lots of pi. Now, plus, remember the area of the base, don't forget to add that on. Pi r squared, that's pi times 5 squared, which is 25 pi. And you can see here that's actually, what's that, 90 pi centimeters squared, if they're centimeters. And you can round that off to some decimal places if you want to. Works out to be about 282.74 centimeters squared. Okay, so it's 2 decimal places. I mean, 90 pi is the exact surface area, but 282.74. Okay, 282.74 centimeters squared. That's 2 dp, 2 decimal places. All right. Okay, now what about the volume? Okay, how are we going to get the volume? Well, first thing is, let's actually write down the volume formula. Okay, I'll just try to rub this out. Okay, so what is the volume formula? Well, volume is what, as we know, 1/3 the area of the base times the perpendicular height. Now you might see we don't actually have the perpendicular height here, but if we look, we can actually form a triangle in here, a right angle triangle in the corner here, using the slant height, L, and the radius. And you should be able to see that there is a relationship between the slant height, the radius, and the actual height of the cone, the h. So let's actually write h. What we're after is h in here. So really, we know that, okay, what? L squared must equal hypotenuse squared, r squared plus h squared. Okay, so we can, or we may even recognize that 5, 12, 13 is in fact a Pythagorean triad, but basically this would be what? 13 squared is equal to 5 squared plus h squared, rearranging h squared is equal to, what's that, 13 squared, 169 minus 25, 144. And as we predicted, yes, h is 12, we're assuming h to be positive. Okay, so we now have the h is 12. So we can now work out what the volume is. It's 1/3 times pi r squared, 25 pi, okay, times the height, which is 12. Okay, we can see here, well, let's just do a few quick calculations. 3 into 12, 4, 4 25s are 100. So the answer would be, what, 100 pi. Okay, that is the exact volume in centimeters cubed. Now, if we want to round that off, 100 pi, obviously it's just multiplying pi by 100, 314.16 roughly. So 314.16 centimeters cubed. Okay, capacity obviously is about, if you like, 314 milliliters, obviously about a third of a litre. Okay, that would be its capacity. Okay, so well, thank you for watching, and we'll make some more volume and surface area videos shortly. Bye for now.